Okay, this is day 2 of lesson 821, introducing imaginary numbers. And yesterday we learned what an imaginary number was. We learned the definition was the square root of -1, and we also talked about the fact that -1 is equal to I squared. So if you square both sides, you get -1 on the left, you get I squared on the right. And we learned how to simplify some expressions. Today we're going to solve some equations that are going to have some imaginary solutions, imaginary roots. Okay? So yesterday we talked about using the quadratic formula. Reminder that this is what it is. When we see this first example, example 1, we don't actually need to use the quadratic formula. If you want to, you could say A equals 1, C equals 1, and see how there's no B value, there's no X by itself. The B is really 0. So you could use the quadratic formula, or we could just make it easier on ourselves and do the undo method. So subtract 1 on both sides. Take the square root of both sides, and remember, when I take the square root of something squared, I have to put plus or minus, okay? And yesterday we learned that the square root of -1 is equal to I. So this equation has two solutions, positive I and negative I. And I'm going to say this a lot of times, but imaginary solutions always come in pairs, okay? Yesterday, we started this. It was example 1 yesterday, but we didn't quite finish. We just said that there's no real solutions. But after yesterday's lesson, we learned we can really simplify this part right here. Okay, the negative gets kicked out, it becomes an I, and we know the square root of 4 is 2. So this is -4 plus or minus 2I all over 2. Now, we never leave it all as one fraction. We're really going to distribute the 2 up through both. Really what we're doing is we're distributing 1/2 to both, okay? And so -4 divided by 2 is -2, and 2I divided by 2 is I. So the one that we started yesterday and didn't quite finish, now we do know there's no real solution. However, there are two complex solutions, okay? Let's think for a second about what this graph looks like. If I have x squared plus 1, it's just my parabola shifted up once. Okay, that's never going to cross the x-axis. That's how I know it's going to have imaginary solutions. Same thing here. If I graph on my calculator, I'm getting a parabola that looks like that. Okay, never crossing the x-axis. Therefore, it has some imaginary solutions. Here's example number 3 for the day. Okay, so if I want to solve this equation, the first thing I want to do is make it equal to 0. So I have to move the 2x to the other side by subtracting, move the 5 to the other side by adding, so that this is equal to 0. Now that it's equal to 0, I could try box and diamond, but my only factors of 5 are 1 and 5, and I certainly can't add or subtract 1 and 5 to make 2. That tells me I have to use the quadratic formula. Quadratic formula, okay? Now remember, when I have any number here and I square it, it's going to end up being a positive number. Okay, all over 2a. So I'm just using this formula right along with this. A equals 1, b equals -2, and c equals +5. Okay, so you want to make sure you get those signs right, otherwise you can really mess this up. Okay, so we get a +4 here. This is -20 all over 2. We subtract, we get -16, and of course that does mean no real solution. That means if I were to graph it, it's definitely not going to cross the x-axis. But from what we learned yesterday, I can simplify this part right here. Okay, I can say 2 plus or minus, the square root of 16 is 4, but there's a negative, so I have an I. Okay, and again we're dividing through by 2 on both parts, so 1 plus or minus 2I. Okay, it's okay to write it like this, x equals, but I want you to understand that it means 1 plus 2I and 1 minus 2I. Again, anytime you solve and you get one imaginary solution, you always get a second. They always come in pairs. One more example for today. Okay, this one looks a little bit crazy, but I promise it's not bad. So this one has a 1 over x, and it has equals to -x plus 1. And what makes this difficult is we're dividing by x. So to undo, we're going to multiply both sides by x. Okay, On this side, the x's cancel out and I just have 1. On this side, I'm going to distribute the x through. So I get negative x squared plus x. Okay, now in order to solve that, of course, I want everything on one side. So positive x squared, because I'm adding it over, negative x, because I'm subtracting it over. I'm not moving the 1, so I keep it a positive 1, equals 0. Okay, and again, here's my 1, and my factors of 1 are 1 and 1, but if I add them, I get 2. If I subtract them, I get 0. That's not going to help me here. So, quadratic formula it is. The opposite of b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Okay, 1 plus or minus 1 minus 4 all over 2. 1 plus or minus square root of negative 3 all over 2. Okay, now this one's a little different from the last ones because we don't know the square root of 3. But we're still going to simplify this. Okay, the negative still pops out to become imaginary. We don't know the square root of 3, so I'm just going to leave it the square root of 3. And again, I don't want to leave it like this. I want to separate it into 2 fractions. I always want my answers in a plus bi form when I can. So I'm going to have 1/2 plus or minus I root 3 over 2. Don't mind Thomas. He's getting hungry for dinner. Okay, so this is my final answer, my final 2 solutions. Another way to write it, which a lot of times it gets written like this, because it's a fraction, we can kind of put that I on the side, and it doesn't look like it's under the square root. Either one of these 2 is right. It represents 2 solutions. One is 1/2 plus square root of 3 over 2i. The other one is 1/2 minus square root of 3 over 2i. And that's all we have for today.